Today we're going to go in a completely different direction of what we've been doing in the past, since school started. So no polynomials right now. We're going to talk about rational expressions. Okay, first of all, so we can't do it on our own or with a partner, unless you have someone in your house that wants to play along, but it's okay. Write two fractions that are equivalent to 1/3 and use slips of paper to create visual models to justify your response. Okay, I'm going to try to split this rectangle into 3 equal pieces. And here we have 1/3. I would shade it in. I'll try, but I think it might hurt what we're doing. Anyway, so let's do that. If I take that same box and I break it into 6, so my big rectangle, I'm going to cut into 6 equal pieces and shade it, shade 2/3 of them, 2/6. So I've got 1/6 and 2/6. Now let's see if I can break that box into 12 equal pieces. Perfect. Now let's color it in. I'm going to color 4 of those 12 boxes in. 1, 2, 3, and 4. Okay, it's just like we stepped back into elementary school. But we are talking about equivalent rational expressions. These are an example of equivalent rational expressions. So we've been working with 1/3. Equivalent fractions. What I'm really doing is multiplying the top, and so the numerator and the denominator, by n over n. So if I multiply the numerator by n and the denominator by n, I'm really multiplying 1/3 by 1. That was messy. Okay, so really what we're saying here is if a, b, and n are integers, and n cannot equal 0, and b cannot equal 0, because they'll both be on the denominator, then n times a over n times b is the same as a over b. I'm saying that n and b can't be 0 because they're in the denominator. And remember, we're not allowed to divide by 0 because the world implodes. I'm just kidding. We can't divide by 0. It's against the laws of math. Okay, if I just wrote a whole bunch of numbers on your screen. If I were to ask you which one of these are considered rational, what would you think? Okay, let's see. 3/4 is rational. 3.14 is rational. 23 is rational. 1.6022 times 10 to the 23rd is rational. And yes, in fact, 0 is rational. Not rational. These would be like pi. It doesn't have an ending to it. 5 divided by 0, because like I said, we're not allowed to divide by 0. Square root of 17, if you take the square root of 17, you actually won't get an end. 1 plus the square root of 5 over 2. Square root of 5 doesn't have an ending decimal. So those are not rational. So of the numbers that were not rational, were they all irrational numbers? No. Okay, 5 divided by 0 is not rational or irrational. Because like I said, you can't divide by 0 and it doesn't work. So today we're learning about rational expressions. They're related to polynomials. We've been studying, it's just just as the integers are really foundational building blocks of rational numbers, polynomial expressions are the foundational building blocks of rational expressions. So really based on what we know about rational numbers, we can come up with what a rational expression is. So let's go to the next slide. Okay, I just want to work through a definition of rational numbers and how they relate to rational expressions. I typed one out to help us go through it. So a rational number is a number we can write as, sorry, I had to sneeze, a number we can write as P over Q. P and Q are integers, and Q is a non-zero. Remember, we cannot divide by Q. We can consider a new type of expression called a rational expression, which is made from polynomials by adding, subtracting, multiplying, and dividing them. Any rational expression can be expressed as big P over big Q, where P and Q are polynomial expressions, and Q cannot be 0, even though it may not be presented in this form originally. So we're going to mess with things so that we can make sure that our rational expression is most simplified, etc., etc. Actually, it's sort of fun. Okay, rational expression. So a description. A rational expression can be written as P over Q, where P and Q are polynomials and Q is not 0. An example. There are lots of examples. Characteristics, it follows similar rules as rational numbers do. And non-examples, okay, we cannot divide by 0, and a number raised to a variable is not a polynomial, okay, so it's not an example of a rational expression. Okay, first example. So consider the following rational expression. 2 times a minus 1, close parentheses, minus 2, over 6 times a minus 1, close parentheses, minus 3a. It says, turn to your neighbor and discuss the following. For what values of a is the expression undefined? So it's really important that before we start messing around with rational expressions, we look at the denominator. And we set that denominator equal to 0 and find out for what values of a is our expression equal to 0, because that's bad, remember? So I'm just solving it while I chat. Take out an 3. I actually didn't have to do that, so let's erase it. Just an extra step. 3a equals 6, a equals 2. So a cannot equal 2, because if we put 2 into our denominator, we would get 0. So 2 minus 1 is 1, 6 minus 6 is 0, and we cannot have 0 in our denominator. Okay, let's reduce the rational expression, which is on the previous page, over 6, a minus 1, minus 3a, where we know a cannot equal 2. Let's reduce it to lowest terms. Since no common factor is visible in the given form, we first simplify the numerator and the denominator by distributing and combining. So let's distribute that 2. Let's distribute the 6. Let's keep going. 2a minus 2 minus 2. Let's see, 2a minus 4, 3a minus 6. Let's factor what we can out. Let's see, 3. Awesome. Okay, I have this in parentheses and this in parentheses and no more addition or subtraction in the numerator or denominator, so I'm allowed to cancel those out. Cool, I just simplified it to lowest terms. So as long as A doesn't equal 2, my rational expression, so 2a minus 1 minus 2 over 6a minus 1 minus 3a is equivalent to 2/3. It is very important, I'm just going to point this out, so hopefully you haven't moved on. I cannot just willy-nilly cancel these out because I have subtraction here, okay? I can only cancel these out because this is just a coefficient with a binomial and a coefficient with a binomial, so I can cancel those out. I cannot cancel them out here, okay? It's just not a valid math move. Okay, let's try these. Why don't you see what you can do on your own, or you can watch the example. I'll do 2A live, and then I'm going to pause for B and just do the answer. So you can decide what you would like to do. It says reduce the following rational expressions to lowest terms and identify the values of the variables that must be excluded to prevent division by 0. Okay, so let's look. I'm going to work first on simplifying the numerator and the denominator. Distribute the numerator. So I have 2x plus 1 plus 2 equals 2x plus, oh, found a mistake already. 2x plus 2 plus 2, which gives me 2x plus 4. Now the denominator. Let's FOIL this first. I get 2x squared. Outer is 2x, inner is 3x, plus 2x, plus 3x, plus 3 minus 1. Simplify that a little bit more. I get 2x squared, let's see, plus 5x, plus 2. Cool. Simplify a little bit more. I can factor a 2 out of the top. I can actually factor the bottom into 2 binomials. Gives me 2x plus 1 and x plus 2. Now, since I have just multiplication, I can cancel. And I'm left with 2 over 2x plus 1. Okay, as far as what your expression cannot equal, what the denominator cannot equal, I'm going to take those binomials and say x cannot equal negative 1/2. And then take the other binomial, and x cannot equal negative 2. So that's part of my answer. Okay, and this is what we do every time we reduce a rational expression. We simplify the numerator, denominator, and then see what we can cancel out from the numerator and the denominator. As a reminder, let's look at B just really quick. I cannot cancel anything top to bottom here because I have addition and subtraction between the terms. But I can factor some things and then try to factor stuff out. So I'm going to do B. I'm going to push pause and do B. If you'd like to try B on your own and see how you're doing, check your answer when you're done. Hold on a second. Be right back. Okay, there you go. Look at the answer. If you're not sure how I came about the answer, just star it and ask me tomorrow. Okay, try another one. Oh, that's B again. We just did it. Let's try the next one. Okay, here's C. So go ahead and try to factor numerator and denominator if you can, and see if you can cancel some things out. I'm going to push pause, okay? Okay, this one has something just a tad bit tricky, which will show up quite often in your problem set. If you notice, my numerator is written backwards from what we're used to, and I want it to match with the denominator. So if I factor out a -1, it becomes -3 plus x which really should be written x minus 3. Okay, and I don't have to write the 1 there. That allows me to cancel out a binomial with a subtraction in the middle that's written backwards. One more. I'm going to push pause. Here's another instance where I need to change the order of my binomial that has subtraction in between. So if I factor out a -1, I can flip the variables, which is pretty cool. Okay, in closing, there's a lot of things I want to make sure we remember. So rational expression, I already typed this out, but let's look at it again. A rational expression is either a numerical expression or a variable symbol, is either a numerical expression or a variable symbol, or the result of placing two previously generated rational expressions into the blanks of the addition operator. So if we had blank plus blank, the subtraction operator, like blank minus blank, sort of hard to read, the multiplication operator, or the division operator, right? How do you reduce a rational expression in the form, oh goodness, P over Q, okay? We're going to factor the polynomial expressions in the numerator and denominator. And then divide any common factors from both the numerator and denominator, which means cancel like terms. How do you know which values of the variables to exclude for a rational expression? You look at the denominator. Anything that makes the denominator 0. Because we cannot divide by 0. Okay, and there's your lesson summary. We really reviewed this in the beginning. So your problem set, I've reduced it. So make sure you asked me before you start working, because there were a lot of problems.